beautiful sight. A whole bunch of tired students. At least not hungry. Somehow it seems like we had a miscommunication about the soda. So I'm really sorry. I'm not sure what has happened. But we'll find out. We have 3 presentations for you today. But 2 of the presentations are from CS370, Dr. Ladin, and the second presentation, the presentation that's going to come second, is a group of students who worked with Dr. Ibar. Let's start with first group of 370 students, Team Wolfpack. Jessica is leading the charge.
Hi guys, my name is Jessica DeVincenzi. This is the 370 project that we worked on this semester. So our project was based off of the Amazon Echo, which is the speaker that is in front of you guys, and her name is Alexa. That's the given name. You can change it, but we decided to stick with it just because it's easy. And what our project was to design a skill that's related to Sonoma State. So a skill is basically, she has many built-in skills, so you could say, what is the weather like today in Roanoke Park, and she'll give you this whole blurb of what the weather is today. So that's a skill, and we had to design our own. So what we did was an events skill, or kind of like an events calendar for Sonoma State. So what the user can do with our skill is basically ask about events that are happening on the Sonoma State campus. You can ask about the academic calendar, and we have all these different types of events you can ask about, so you can narrow it down to what you want to hear about for that day, and the types of events are listed up here. They range from athletics all the way to lectures and some other fun things. So there was a lot of implementation that went into this, and the very first thing was finding a calendar that we were able to actually pull information from. So up here, it's kind of actually really small, but this was the calendar that we found on the Sonoma State website, and something that we ran into was an issue with finding the right type of calendar. So this one, you can see it has things listed like title. I can't read that, but it has some stuff listed and has clear values for those. So we were able to find a calendar that was scrapable, and we created a scraper in Python that could pull the information from that and store it into a database. And so from there, this is just a little screenshot of our database and all the events that we have. Up here it says we have 501 events right now, and these are just some of them. So we pulled the important information like the title of the event, the description, the start time of the event, and the date. And then from there we put it all together and used certain things that Amazon provides for you, like the Alexa School Skills Kit and some other tools to build a working skill. So some of the things that our skill does, well, in our class we had to present every few weeks, and so we started off with something really small that we ended up hard coding and found out that that didn't really work. So at first we built a little thing that you could use to ask for the Lobos Daily Special, and then from there we started using our database, and we were only able to ask about the next event, and still you could do that. It's not that exciting. It just gives you like the very next event that's happening on the campus that we have in our calendar. And then from there we started to really expand on it, so you could ask about the next event, and then you could ask about things on a specific date. And if that specific date had 5 or fewer events, then you would be able, or she would just list off all of those events. But if it had more than 5 events, then you can narrow it down by category. So there's where you would say, I want to hear about sports, or I want to hear about lectures and films. And then this is just an update, so all the things, we added more things like price. And then let me see if this is working. So in many skills that are built in, they have a start intent, and that tells you about what you can do with the skill. So if we say, Alexa, start events. Just kidding. Alexa, start events.
Welcome to the SSU Events skill. You can start by asking me what's happening today or on another upcoming date.
What's happening today?
I was able to find 8 different events on Thursday, December 1st. What kind of events would you like to hear about?
Tell me about sports.
Sure. Here are the athletics events that I was able to find. On Thursday, December 1st, there is IMS volleyball at 7 p.m. and intramural indoor soccer at 8 p.m.
So those are just some things that she does. Alexa, stop.
The next event is IMS volleyball on Thursday, December 1st at 7 p.m.
Sometimes that happens. We'll just let her go.
Okay.
Alexa, stop. Okay. So yeah, sometimes you run into bugs, and she gets confused. There's a lot of putting in utterances that she will understand, and finding out the ways that different people say things and how they want to ask for certain details. So we can ask about things on a specific week or weekend. So we could say, Alexa, what's happening? Shoot, I asked her wrong.
Good afternoon. It's 12:10 p.m. Here's the latest. It's 56 and partly
Alexa.
sunny.
Stop. So the thing is, you have to ask for the event name or our skill name. So you have to say events for it to work. Alexa, ask events what's happening this weekend.
I was able to find 26 different events this weekend. What kind of events would you like to hear about?
Alexa, stop. Okay, so she will go on listing a bunch of events for you, and I'm not going to go through that because sometimes it's a really long list of events. But we added some things about, expansions on that. So you could even ask her how much an event costs. So for the category of lectures and films, that's a good one. Sometimes these things cost money, so you can ask about the price of an event. You can ask about where it's located at. You could ask about the ending time, because our skill just lists the starting time. So Alexa, ask events what's happening on December 5th.
I was able to find 14 different events on Monday, December 5th. What kind of events would you like to hear about?
Lectures and films.
I couldn't find any lectures and films events.
Okay, just kidding. But if you find an event that you would like to ask about, you can expand on that, and she'll give you the price and all those things that are up there. Another fun thing that we added is our academic calendar. So this was something that we actually had to hard code in versus everything else that we were able to pull from the database. These things, the calendar that's on the Sonoma State website is not easily parsable, so we just had to write all this stuff in. But you can ask about cool things like when are finals, and she'll give you the answer. This one's cool. Alexa, ask events, is there school on December 5th? Okay. Alexa, ask events, is there school on December 5th?
Classes will be in session on Monday, December 5th.
Alexa, ask events, when is winter break?
Winter break begins on Saturday, December 17th and ends on Sunday, January 22nd.
So those are things that we thought the user would find really useful, and things they would really want to know about. So one great thing about our skill is that it will keep going for as long as there are events on the school website. So our scraper scrapes automatically every 10 minutes and puts new things into the database and updates it, so it will keep going. We don't really have to update it constantly. And then the only things that we do have to hard code in there are the academic calendar events. Done? Okay. But those are in there until 2020, so that's good. And then this was my team, and that's it. Any questions? questions? No? Where? Oh, hi. Yeah, what's up?
What did you program the stuff for Alexa in? What language?
A lot of Java. Then we use Postgres SQL for our database, and our scraper was in Python. Anything else?
And JSON.
Yeah.
And schema JSON coded.
Yes. Okay.
Questions for Jessica? Thank you so much, Jessica.
Yeah.
So our next group, Jake is going to present for the next group of 3 research students who worked with Dr. Ivoire.
Okay, so we did this over the summer where we, so this was an extension of some previous research that Ivoire did with identifying power traces. So we have these power traces of 2 different programs. The left is the fast Fourier transform, right is Scublast, I believe. And you can look at seeing them, they're very different how we can see them, but the thing is we try to train a computer to do this. So what was previously done was they were, each trace was turned into a bunch of statistical features like min, max, mean, median of all the values. And we got 14 of these. And then we trained a classifier to try and determine what these are without knowing what's in them, or to be able to determine what the power trace is without knowing what it is. So we train a classifier. We get about 85–90% accuracy with training it, but this has some limitations. I'm only going to talk about one. These are old slides that I meant to delete a lot of this stuff, but basically, we're going with this one. This is what we deal with. We can't. So the problem is that if we have 2 traces that we know, but they're concatenated into one, we can't deal with that. So what we did is we tried to figure out how to parse multiple traces, or how to figure out if multiple traces are concatenated together in a single trace. So to do that, we need to figure out first where we need to find where the one trace ends and another begins. Then we have this phase that we now have to figure out what that phase is. And then we try to figure out what that is, and then we try and partition it correctly to get all of them correct. So our data set, we have 388 traces from 21 different types of programs. There's the list of them. And then for our experimentation, we would pick 5 traces randomly of the 388. We would concatenate them together. Then we take the other 383 and we train a random forest on that. And then for correctness, we figured out how many individual data points we got correct as a percentage. So first thing we do is change point detection. So since we know that we can break them into a list of features, we should be able to figure out where one trace ends and another begins. So what we need to do is, if we can find the actual split point, then a lot of the noise in the thing is fine. So what we did was we used a wild binary segmentation. Normal binary segmentation wasn't as good. As for why, the guy who will be able to tell you that, I don't think is here. And then here's a visualization of what it looks like. The dotted lines are the detected change points. The red lines are the actual change points. And as you can see, there's the first trace doesn't end until about 7,500-ish. And there's a lot of extra ones in between, but that's not really much of a problem because the algorithm will so we have recall and precision. Recall is, so we have these change points that we found. Recall is how are the correct ones in the set of change points. And then precision is how much of it is noise. So we almost always get the correct change points, but we also have a lot of noise, which doesn't affect the accuracy of the program, but it makes it take a lot longer. Because I'm going to skip minimal because we do the maximal approach where we test all possible combinations of these pairs. So and just to treat it as a candidate phase. So we have a visualization here. So the first one will lead to the second, third, fourth. The second one will go to all the ones after. And then we get the traces in there. Or we get the set of data points in there, and then run the and get the features out of it, and then run that through the classifier. And we weight the edges of the graph now. We weight the edges based on how accurate the classifier thinks it is. So we weight it by using certainty and proximity. Certainty is how many, so we use random forest, which has a number of randomly generated trees, and it'll throw the data set in there, and it'll have at the end some prediction of some sort. And then certainty is how many guessed the best option. And then proximity is a measure of the path taken through the trees. And then we weight it by the interval length, so we have certainty plus proximity times the length. Then we turn this into a directed graph, and then run a longest path over it. So in this, the green lines are the correct result, and the red lines are what the algorithm predicted. And the number is the certainty, or the certainty plus proximity attached. So in the first one, you can see that it got 2/3 of it right, then the last third it got wrong, but that didn't really affect the overall algorithm because it ended at the same place. The second one shows that we can have a lot of noise, it can have a lot of change points in the middle, but it'll still get it correct. And the third one is, it's orange because that change point was not detected, but it still got one kind of nearby, and that didn't affect the algorithm much at all. So it's resilient to not finding the exact change point. And as far as correctness goes, over 300 runs, the total correctness was about, the average I believe was 78%, the median 90%, so it came out pretty good. And so came out about 70%. This does have some possible improvements, but that's the slide I removed. So questions? Yep.
What is a power trace?
A power trace. I should have gone into that. Basically, we had these computers. We had measuring of how much wattage it used, or how much energy, how much electricity it used. So we plugged it in. We ran a program on a computer, and then checked how much power it used over the course of that program's runtime.
So what are those? There were those points where those red points. What do those represent?
On here?
Yeah.
This is where one program ends and another begins.
Okay.
So throughout the runtime, so I guess here is where one of the traces ended, and another one began. So the red is where, because this is 7 concatenated programs together. So power traces 7 programs together.
Do you have to use special equipment to measure this, or can you do this with consumer hardware?
I believe we used I guess, I was not part of the measuring team, this was before my time, but I believe it was a Watts Up Pro. Revar can tell me how much it cost.
It's extremely crappy. Depending on the exact edition, like $75 to $200, and like 1 sample per second, like totally consumer grade.
Possible way to make this better is to try and have more higher resolution measurements, but that's the future thing. Yep.
What causes those changes that lead to like the false?
Just how the program runs. Sometimes it just has like some dead time where it just does something. Like I don't know if it just waits for I/O and just like stuck there for a while. Again, I didn't do the exact measurements, so I don't know like what these exact programs do. But programs of a similar type will have the same sort of like downs and ups and stuff, so you can accurately predict what they are based on those internal change points.
Other
That's
questions
it.
for Jake? Thank you very much, Jake. All right. So, just a bit of more information about these presentations, the first one and this one. Dr. Levine had 2 sections of CS370 this semester. And he used Echo as the platform for projects that students did for the course. FIS Mobile and provided the devices. Jeff Nyong is one of our alumnus who works at FIS Mobile and has been very kind to us. So we have these devices due to him. And also he's going to have internships. He has started the internship program on his own. And he had a meeting with some of you this semester, and he's going to come back and have more meetings with you regarding the internships, okay? I just want to mention this, and we're grateful that he is so kind and he supports us so much. Our next speaker, Jacques, is going to present the next project, the last project.
All right. Can you do the...
Oh.
Thanks. All right. So, hello everybody. We are Death Records, and this is our 370 project, Amazon Alexa. So, first off, I know a lot of you aren't familiar with Alexa, so what is Alexa? It's a conversational user interface coupled with cloud-based computing. So, conversational CUI, it's pretty self-explanatory. I speak, she listens. And it's a one-way street, but we're working on making it a two-way street to have more immersive conversations. So essentially, this is Echo. It's just a device. It's kind of just a glorified speaker with a computer inside of it. But the real what's important about this device is its ability to communicate with the cloud. And it beckons the question of, how does Alexa work? So, yeah. So, Amazon created this Alexa voice services, which basically records the user's voice and...
I can't find the answer to the question I heard.
I'll get to that part in a second. But it records the user's voice and it converts it into commands, which it reads later on. So, like any English sentence, we have structure. So, first is the wake word. So if I say Alexa, you see how her light comes on? She's awoken. So, number two, we have an invocation name. So we have horoscopes, or what's the weather, or sports, or calendar. And that basically tells what skill to map to. So what's a skill? A skill is a built-in capability, and we use it to tell her what our skill we are working with is, which maps to intents. And intents are essentially JSON structures, which declare valid utterances. So from the intent, we map to an utterance, and that helps us to ask, well, the user asks what they want, and we have a bunch of variations of how to ask. So if you wanted to say, what is the weather, how is the weather, we created all these variations so that we can get the information that the user wants. So utilizing the Alexa voice services, we've spent all semester teaching Alexa a new skill, which is Professor Lookup. So what is Professor Lookup? Professor Lookup is the student secretary. So you can ask her, what is Dr. Smith's office hours? Or where can I find Dr. Smith? Or can I have Dr. Smith's contact information? And where we started was with 15 utterances. So we basically have to hand type all of these things in. And a paper program, just a bunch of storyboards, a simple idea, and limited hard-coded resources, and lots of silence. Go ahead. So where are we now? We have full SSU app API integration. So previously we were using MySQL, and we created these hard-coded databases, and that was just not working out too well because of the conflict of, oh, what if Dr. Smith or Professor Smith's location changed? So luckily, Eric Amorde, a student here, created the SSU app and gave us full access to his API. And now we can just, our JavaScript, or our Java goes directly into the SSU app API and extracts all the professor information. Levenstein function. One huge impediment in our project was finding a professor name. So disambiguation of professor names. So we were using Dr. Kushesh as an example a lot. And for example, we would say, find us Dr. Kushesh's contact information. And it would give us Jana Kushesh on a consistent basis. So we added the parameter of adding the first name as well as the last name. And what the Levenstein function does is it measures the amount of insertions and deletions of a string in order to change it to the key. And then by doing that, we're able to find what the user wants, essentially. So yeah, that was a huge impediment. That was like the iron curtain of this project, and we just took a sledgehammer to it with this Levenstein function. And 500 utterances from the previous 15, and conversation with def. So previously, we would just ask for a professor email. She would respond, and that would be it. And that was probably the second biggest issue with our project, because from the names, we couldn't go any further. So after we got the names, we were able to draw the 3 different types of information and kind of circle around. So the conversation, so these are the intents we created. So we have office location, contact information. Repeat is pretty important. It extends the conversation. More info does that as well. Amazon help and stop are implicit intents inside Amazon's web developers kit. And we wanted to make a sassy Alexa. That's what we called it. So we put some jokes in there too. And then, you want a demo?
Oh,
all right.
Sure. Alexa, ask directory for help.
Here are some things you can ask to get a professor's location. Where can I find Professor Smith's office, or locate Professor Smith? To get a professor's contact info, say something like, what is Professor Smith's contact info? Or get me contact info for Professor Smith.
Alexa, ask directory for Kushesh's contact info.
There was a problem with the requested skills response.
Or don't. Alexa, ask directory for Morris's contact info.
Did you mean Jerry Morris or Kathy Morris? Say first and last name, please.
Jerry Morris.
Would you like Jerry Morris's email address, phone number, or location?
Phone number, please.
Here is Jerry Morris's phone number, 1-707-664-2199. Would you like me to repeat that or give you more info on Jerry Morris?
More info.
There was a problem with the requested skills response.
She does that sometimes. But just one aspect of that was when you're asking for the phone number, previously she would just rattle off all the numbers. So she'd say, so-and-so's contact number is 17700, and just spit it all out at you. So there's this thing in Amazon Web Developers Skills Kit where it's called SSML, where we can create spacing. And it's a lot of use of commas and
it's not just for Amazon. It's a standard for speech recognition and speech output. It defines whether you want to spell out or say something in a certain format. So if you want to say a phone number, there's a built-in function in there that that takes a phone number and knows it's a formatted number, and it'll space it out so it's not as quick as like 1707 2 whatever.
Yeah.
But, yeah.
Cool.
Go ahead. My bad.
So that was some of the demo, and then do one more.
One more?
Yeah, do
What
one
did
more.
you
No.
Oh.
So yeah, like Dr. Kushes was saying, Jeff Young helped us out a lot. He was available via email and came by, took time out of his day, out of work, and donated these echoes. And he's from FIS Mobile. And then Eric Amorde was a huge part of the project as well, because he gave us the API and full access to SSU app. So if you guys ever want to talk to them, they're open to help. And just want to say thank you to them. Cool. And that's my group over there, Death Records. Yeah. They worked really hard. So yeah, that's our presentation. Oh yeah, the joke.
Alexa, ask directory for a joke.
We hard-coded this one.
This is pulling from a database, so.
Why did the Java programmer need glasses? He couldn't see sharp.
Sometimes the connection to our database is a bit slower, so it takes a little bit longer, as you guys just saw.
Yeah. And we wanted to put jokes in just to make the conversation more fun.
Yeah,
so you want to use her more often.
The jokes are also offered as a reprompt. So if say, Alexa, ask directory for Kushesh's contact info.
There was a problem with the requested skills response.
Sometimes it doesn't like.
It thinks your name's Cushions when it comes into the
Alexa, ask directory for Revor contact info.
There was a problem with the requested skills response.
Yeah.
All right, so my bad.
Last time.
Alexa, ask directory for Morris contact info.
Did you mean Jerry Morris or Kathy Morris? Say first and last name, please.
Jerry Morris.
Would you like Jerry Morris's email address, phone number, or location?
Location.
Jerry Morris can be found at Darwin Hall. Would you like me to repeat that or give you more info on Jerry Morris? I didn't catch that. Would you like me to repeat their location or give you more info?
Okay, usually it's supposed to say like, do you want a joke or something, but
Yeah. There's still some
we can
bugs.
also say, give me a joke, and it'll process.
What do you
that.
call a guy who never farts in public? A private teacher.
A what?
I don't know.
Oh, a silent tutor. But yeah. So that's our project.
Thank you.
Thank you so much. It seems like it really didn't like computer science faculty. The math faculty. Our feelings aren't hurt. So, of course, this week is almost over. We have one more week to go. I know these are hard times, stressful times. Hang in there. Let us know if you can help. I sent out an email regarding the two courses that we're going to open, the two new sections that we're going to open. We're going to open a new elective. We're in negotiation with people who might be teaching them. So at this point, I don't know which topic it's going to be, but it's going to be something that requires CS215 only. And then the other one is a second section for CS47. That too, we haven't exactly come up with a time. Once we do, of course, I'll let you know. Thank you so much for coming. Oh, yes.
Could I say something?
Of course.
If anybody
Dr.
is,
Plants.
if anybody in here is taking 252 this semester, or you know anybody who's taking it, this is the first time my book has been used, and I would really appreciate people taking the time to, at the end of the semester, to give me feedback. So if you know any other students who are using it, it's the first time it's been used. I want to be able to update it and tweak it for future use. And my email address is either the campus one or bob@computer.org, which is easy to remember.